Welcome back, my dear friends. Class 12 Mathematics, Chapter 4 Determinants. Let us continue with the properties of determinants. Using properties of determinants, show that question number 8.1. So, as we have learned earlier, these are all again based on operations of like transformation of matrices. No operations on matrices, transformation of matrices, sorry. And then, of course, we have already studied some uses of some properties of determinants. Now let's try to solve all of those. Now if we just take the left hand side, now we are not solving all the questions from the exercises, okay, but it doesn't mean that we are not there to help again, because I'm just doing some of the questions, some common questions from the exercises, and now it would be your duty now to like try and do the other questions at home. And then if you are not able to do any of the questions, then please leave a comment or email us letting us know which question from which exercise you would really like us to solve. We would be glad to help. So with that, we'll also be encouraged. Now here what I've done is I'm using transformation of matrices, that is operations, elementary operations on matrices, on determinants also. So I've done a video on the elementary operations of matrices, so please go through those videos also. So now in those videos we have studied that we can apply this kind of operations, that is on determinants. We can subtract any two rows or columns, or we can even add rows or columns. That's what we can do. So here what have I decided is R1 and R2 I'll make some changes, and we know that the value of a determinant remains the same if only the rows and columns are interchanged. Now R1 I will use this operation, that is R1 minus R3, and R2, that means R3 I am not going to change the operation, I'm not going to do anything. So R3 I'll write as it is. R1 I'll use R1 minus R2, so R1 minus R2, R3, sorry, so 1 minus 1, 0, A minus C, A square minus C square. Alright, and R2 I will use R2 minus R3, R2 minus R3, 1 minus 1, 0 again, B minus C. Now this kind of exercises, the more problems and the more varieties of problems you solve, the more operations you learn, because like there is not a fixed operation like, okay, you can do this, you can do that, you can do this, you cannot do that. No, we don't have that list. Okay, it may be, but it is an unlimited list. We cannot put a stop to that. No, the varieties of operations can be done. So the more problems you solve, the more varieties of solutions you will come across. So, and more options, no more variations of different operations. So please do that. So now once this is done, what I will do is, okay, 0, 0, 1, A minus C, B minus C, C. Now A square minus B square formula I will use, A plus C into A minus C. Here also B plus C into B minus C, C square. Now from determinants we have seen that we can take an element from a particular column or row. So from the first row I am going to take out A minus C common. From the second row I will take out B minus C common. So in that case what is left? 0, 0, 1. Here 1, 1, C. And here only A plus C is left now, and here B plus C is left, C square. Alright, so now proceeding further, so I will leave it as it is, B minus C. Now I will expand along this element, so that will be leaving this row and column. That will be, other elements will all be 0, because it's going to be like because I'll be expanding along C1. Okay, so here 0, here also it will be 0, because even if you cross multiply it will be 0. You take the minor of this also will be 0. because 0 into anything is 0, so only 1 will be left. All right, so 1, so this is the element of A, 3 1, so this will be positive, no problem. So that will be leaving this row, so B plus C minus A plus C, just following the concept of minors. So then we will be left with, sorry, A minus C, B minus C, B plus C minus A minus C, C gone, A minus C, B minus C, B minus A. So our proof was A minus B, A minus B, B minus C, C minus A. So it's okay if you want, we can take a minus common, C minus A into B minus C as it is, into from here minus A minus B. So minus, these are all products, so minus into minus, minus into minus will be plus, so we can just arrange A minus B, B minus C, C minus A. So this will be the proof. Moving on to question number 10. Of the proof, x plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4 is equal to 5 plus 5x plus 4, 4 minus x. It's not only with matrices, okay. Mathematics, the more you practice, the more varieties of problems you come across, the better you become. So mathematics, the only trick is practice, 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 and practice. There is no shortcut in becoming swift in mathematics. Now in this operation, I can see one hint, that is like 5x here, no? The proof will also always, most of the time, give us the hint, okay, exactly what to do, which operation to apply. Now when I look at the proof here carefully, 5x means 2 plus 2, 4 plus 1, 5x. Or even this way also, 2 plus 2, 4 plus 1, 5x, isn't it? So what I'll do is I'll just change any one row or column. So let's say column 1 I'll change. Column 1 I'll add column 1 plus column 2 plus column 3. So column 2 and column 3 I am not going to change, so I'll let it right as it is. And column 1 will be column 1 plus 2 plus 3. So 5x plus 4, here also 5x plus 4, here also 5x plus 4, isn't it? 2 plus 2, 4x plus 1, 5x plus 4. Now I can take 5x plus 4 common. So 1, 1, 1, 2x, x plus 4, 2x, 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 x plus 4. So again, proceeding further, what I will do is maybe row 2, that's up to us what we can do. We can think of maybe column 1. So what we can do now is, okay, R2 we can write as, because proof is 4 minus x, okay, so 4 minus x, okay, R1 minus R2, R3, R1 minus R3. Let us just try. If it doesn't work out, it's okay, we can redo it again. So row 1 I will not leave, I'll not change anything, I'll let it be, I'll let it as it is. Row 2 will be R1 minus R2, 1 minus 1, 0, 2x minus x minus 4. What was our 4 minus x? Okay, let us, okay, what we'll do is, instead of this, because along with the proof we'll try to do now, R2 minus R1, R3 minus R1. So let us move in this direction, not in this direction. 1 minus 1, it's all the same, 1 minus 1, 0. X plus 4 minus 2x, so it will be 4 minus x, 2x minus x, 0. Again, R3 also. R3, that is like R1 is the base, no? Something like this. R1 minus 1, 0. 2x minus 2x, 0. Again, x plus 4 minus 2x. That will begin 4 minus x. So now what we will do is we will expand along C1. So that will be 1 into 4 minus x, 4 minus x minus 0, and the other elements will be 0 because expanding along C1. So for this element we already have the determinant minors. This, for this, anything into 0 will be 0. For this also there's no point in proceeding now, because 0 into whatever you get will be all 0. So we have 5x plus 4 into 4 minus x whole square. The remaining all the terms will be 0. So I think that's our proof. 4 minus x whole square, 4 minus x whole square. Perfectly fine. So this is how we will be using transformation, limited transformation and transformations, and then of course using its properties also to prove. So there are more problems. We'll try to solve some more problems in the next video. So please go through the videos and do share what your experience with this video classes, online audio classes that we are providing for you, and if it is really beneficial for you, please do leave a comment below, and then do encourage us to help you more. And if any questions you would like us to do, please leave a comment below, so that we will also be encouraged, and we will also know that students are watching this video and learning from this video, so that we can provide you more and more videos. So stay safe, stay at home, from the team of Teach Nagaland, and help us reach more and more friends. Thank you.